concept. Okay. Now see the situation. The arrow mark not going inside the box is a request. Okay, that means what? P1 is requesting R1. The arrow mark starts from the dot and identifying the process. This is called allocation. That means what? Resource R1 is allocated to process P2. Now, what does it mean? Process P2 is requesting R3. R3 is allocated to P3. Okay, R3 is allocated to P3, or in other words, P3 now currently using R3. P2 currently using R1. Okay. Now, R2, resource R2 is allocated to process P1. This is allocation. Resource R2 is allocated to process P2. See here you can have one confusion, sir. A single resource, why two processes using? That is not allowed. Yes, that question you may ask. But here it is not a single resource. It is two number of resources of same type. For example, two printers. Okay, two printers. Here may be some other hard, any other, for example, plotter. For example, here any input device, keyboard, like that, you can have different resources. Okay, so two dots means two numbers of resource R2, of type resource R2. So what does it mean? Three instances are there, or three numbers are there under resource R3, sorry, R4. R4 is one resource, three number of R4s are there. So it doesn't mean a single resource is used by two processes, not like that. Two different resources. This is R21, this is R22, that's all. Okay. Now quickly you answer in this situation whether deadlock occurs or not. How to check whether deadlock exists or not? I will see. Let me explain. See, what is first condition? Mutual exclusion. Mutual exclusion means what? When one resource is used by other resource, and when one resource is used by a particular process, other process not allowed to use the resource. Okay. This is common default fact we cannot change, or this condition we cannot eliminate. This is universal truth. When one resource is used by a process, that resource will not be allowed to used by any other process. Okay, that means what? One process, one resource at any given time. So that we cannot change. So by default, this condition exists. No need of any confusion in that. Okay. Second one is hold and wait. Hold and wait. See, P2, sorry, P1 is holding R2 and waiting for R1. Correct? 1. Consider P2. P2 is holding R1 and one instance of R2 and waiting for R3. P2 is also hold and wait. Consider P3. P3 is holding only, not waiting or not requesting anything. Now you understand one condition. In a given graph or in a given situation, if all the process having the condition hold and wait, then only deadlock exists. Okay, all the process in a current situation applies hold and wait condition, then only deadlock occurs. So here, only process P1 is performing hold and wait, P2 is performing hold and wait, P3 is not performing hold and wait. Okay, so there is no any deadlock. Okay. So once if you find any one condition is false, immediately you can say there is no deadlock, no need of checking other two conditions. Okay, without checking other two condition itself, we can say or we can declare there is no deadlock. Anyway, we will see another condition also. What is that condition? No preemption. This is policy decision. Whether you are allowing preemption or not is policy decision. That condition also we will not change it. Let it be like that. Okay, so first condition and the second condition, no need to check for deadlock. Why no need to check? It is default condition that always exists. So you have to check only these two conditions, hold and wait and circular wait. So here hold and wait condition is false. Okay, this condition becomes false. Now we come for circular wait. Try to form any circle. So I am starting from P1 go to R1, then P2, then R3, then P3. There is no any circuit. Again, I'm starting from R2 in this direction, P2, R3, and P3. There is no any circuit. Okay, you can start from any process or any resource. There is no cycle, so surely you can say there is no deadlock.